So, good morning. Andreas and I will give you a presentation. I will do the presentation. Andreas will give the demonstration of our tool. And so what we have reached so far, and it's by far not complete, but hopefully it gives you insight in what we will end up with. And also we hope to start a discussion on what we should focus on. So my name is Bart Luijten. I'm from TNO. TNO is a Dutch research institute. And Andreas?
Yes, my name is Andreas. I'm from Strusoft Sweden, Malmö, south of Sweden. We're a software development company, so I'm focusing on that.
Thank you. And we have Rasmus. He is in Sweden at this moment, Göteborg, and he's from SP, the Swedish Research Institute. So, I will start with a presentation. Yeah. So we are developing an integrated decision support system. Now, it's a mouthful, but what does it mean? So the main thing is about support. We build a system with computers and stuff, but decisions are made by people, not computers. So we only support decisions you are making, you are discussing with your colleagues. We also focus on real decisions about investments. So for a housing company, it's good to have a strategy in general and where you focus on, but also for this complex, we have to renovate it, how do we do it? Or for an electricity company, do we focus on PV panels, stuff like that. Real decisions, concrete decisions, investments. It's integrated. We don't look only at just at energy or just at material use. We try to combine all aspects of sustainability: people, profit, planet, process. And the hard stuff, the measurable stuff, and the soft, the so-called social stuff. And it's a system. And the system is part in the computer, but it's also the sessions you have together, stuff like that. So it's not only computer programs, but also the process of interaction. The example I will talk about and what we will use in the demo is Rubroek. Now, I don't ask you to pronounce it, but it's a district in Rotterdam. Okay. I can't name it, sorry. Shall I sit down? Is it better?
Maybe it's better.
Yeah?
Yeah.
I just sit down and okay. Okay. So, sorry you didn't hear me. I'll talk in the microphone now. The district we are talking about is Rubroek. It's an area just outside the center of Rotterdam. A little bit more than 4,000 houses. Half of it owned by the housing corporation, half of it is privately owned. Now Paul is here in the audience in Valencia, and he's from the housing company. And so the housing company really wants to do something with this area, with the houses. They have to. They are from the 70s, 80s, and a lot of the technical installations are sort of at the end of their technical lifespan. So they have to change the heating installations, etc., etc. And if they want to do it, they can do it the normal way, just put in a new heating system, or do it a sustainable way. But if they don't do it sustainable today, they have to wait another 20 years, 30 years to to do something in this area. So they really want to do something with it today, and they have some opportunities for that. And also other stakeholders like the city or the water board, they don't have much money. That's a little bit of a problem, but they have some ambitions in this area. And in this area, there's socially, so it's not the biggest problem area in Rotterdam, but it's also not too good. And there is a risk that they will slide down if nothing happens. So there are some social groups and activities, communities that want to steer up the area. So it's an interesting area for us, and with all the stakeholders, and how can we support them with our IDSS. In the demo, we will only look at energy, but in the case, we had a meeting last Thursday, we look at all aspects. So the agenda, I'll explain a little bit about the process, what we think is a good decision process. Hey, can you switch it out? Yeah. And what is a good decision process? I explain you the role of the IDSS in it, and then finally we will go to Andreas to see the real stuff as a demo. And hopefully after that we have some discussion. So this is, does it work? Yeah. This is the generalization of our decision process. It's not too difficult. So first you define your ambition together, then you decide, and then you realize, and you monitor, and you have some feedback and analyze again. For ECODISTR-ICT we focus on the first two stages, defining your ambition together with all the stakeholders and make your decisions. So let's zoom into each of those, the orange and the grey one. So the ambition process. The ambition process, we have modeled it in 4 steps, and this is 4 natural steps. So first step is to analyze your problem. So sit together with the stakeholders, and what is our joint ambition on a high level, and what kind of indicators do we have? First, each stakeholder on their own. What indicators do you have to, that you want to reach in this process? So the key performance indicators. Then you collect data. What is the current state? And you analyze sort of the as-is situation. So how many, or what is the average energy label, for instance? And the fourth step is then to define your ambition. So the current energy label average is D, and we want to have, in 10 years time, we at least want to have energy label B, for instance. So you can do that for all KPIs. So this looks like a linear process. Of course it's circular, you go back and forth in all steps. But you will see those steps in the demo of Andreas. The second big group of steps is about the decision process. So first is develop a number of alternatives. So based on your analysis, based on your ambition, you define a number of alternatives. Now, in the energy area, one alternative might be we go all electric, place some windmills in the area, PV panels, or another alternative would be to use district heating. From the energy, the power plant, that you have surplus of heat, maybe you can use that. But of course these two options, they need completely different investments. So those, you have two alternatives. In the second step, which actually is altogether the sixth step, you assess those two alternatives, and you now calculate future energy use, return on investment. What else do you have? And then in the last step you select the best. And again, the computer doesn't select it, you do it in a joint process. And as you can imagine that, again here you go back and forth to the steps. So if you develop an alternative, you assess it, and then it still doesn't work. So then you go back and improve your alternative. Finally, you come up with a well-founded decision, or you end up with the notion that you cannot reach your ambition. But the fact that you have a well-founded decision is also very important in the stakeholder process. Then you can see that maybe I have to give in a little bit, but others gain a lot. Or it's a proof that maybe I pay a little bit more rent today, but next year my energy bill will go down a lot. And so that will help to convince other stakeholders in this process to stand behind the decisions you have made. So this is the 7 steps in our decision process, and you'll see them in the demo of Andreas. So let's have a short look at our system, integrated decision support system. So basically you have 3 groups, or 3 groups of components, which are here. Yes. Where do I start? So let's start with the dashboard. So this is, when you have a group process, this is what with the group you see. On the other screen, which behind Andreas, this is the dashboard. So this is for facilitating the group process. And Andreas is acting as a facilitator of a group decision process. So on the other hand, you have the modules, the computer programs that calculate energy use or calculate return on investment, stuff like that. It's used by more expert users in the back office. And the framework connects everything together. Now let's see. And you can elaborate this further. You have a number of modules, and some of the modules need an expert user behind the computer, and other modules are more simple, can be automated. And the dashboard, what you'll see, the dashboard also runs on a server somewhere in the cloud, and you have a client computer program, simple program, which can be used on on all kind of computers or devices, etc. Let's go one step further, and then I give the floor to Andreas. This is a little bit more elaborated, and you see at the bottom you see 3 types of modules connected, and in this example we'll have the PV panel, another PV potential, and CO2 or the energy use. Now, Rasmus in Gothenburg is the expert user behind the CO2 program. Reinier in Delft, he was the expert behind the program, but today he's not here, but Andreas will run it on his own. It's also an automated program. So it's in Delft, but it runs in Delft on a computer in Delft. Then the whole backbone, the communication backbone, also runs in Delft. The server of the dashboard and the database of the dashboard runs in Ireland, and we are here today in Valencia with Andreas behind the computer. So it looks very complex, but the good thing about this is that this allows you to have computer applications running at those places where the experts are, and on the data level it also allows that you have the data in one place, so you don't need to copy and send data all over the world and from one to the other to all stakeholders, and then then you don't know whether everybody has the good data, the right format, etc. So you centralize data storage and applications. So this is what we have today on the demo, and we will talk to Rasmus later.
Yeah.
I give the floor to you.
Thank you very much, Moritz. Yeah. So I will show you the demo on dashboard, whether it's quantitative or qualitative, and whether there is a unit. Probably if it's quantitative, it has a unit. And there might be more settings here coming up, because we want to define something, we want to make the KPI quite powerful in itself. But it's very important that you could, for example, choose to have a qualitative KPI, that you discuss whether something is good or bad. That you can't measure it really, but you want opinions about things. But now I will just cancel that, and I will use these two public KPIs. On the right hand side, I now want to configure these KPIs, because for every process it will be different relation between the KPI values and what was interesting for you. You can see there is an exclamation mark here, and that actually says that you have to do something now. We cannot use this KPI before you say something more about this. So for the energy KPI, we can define what's excellent and what we think is a bad value. We can define how important this is for us. So everyone that logs into the system can put their own priority. So that is weighted then when you assess alternatives, what's important for whom. So first of all, I want to put what is an excellent value for energy consumption, which is 0. And then a bad value, in this case 12,000 kilowatt hours. I will leave the priority to 3, to mid important. But now I do a very important thing, and that is I connect this KPI to one of the relevant modules, and this is the Rasmus module. Okay, and you will see later that from now on, everything that we will see by using this KPI will have a lot to do with the module, the inputs and outputs of the module. This will affect this KPI a little bit in the process, because every module has their own inputs and outputs. They give different kind of results, give different details and stuff. So this is the flexibility of the dashboard, and I will show it a little bit later. I will press OK, and I will do the same thing for the PV production. But this time we want to have a good value, higher the better on excellent, because that is the potential for the PV, and bad is 0. It's the other way around. And here I will also select the module, like that, PV module. Okay. So, no exclamation marks. This means that we are ready to go to the next step, and that is actually to collect data. So that we have analyzed now the problem. So,
Yeah. Let's start. So I tell you a little bit more about the data collection part. So in general, there are 3 sets of data you need when you want to calculate. So the first set is the as-is data. So how does the area look like today? What are the houses, the characteristics of the houses, the people that live there? Now, for this example, their current energy use, stuff like that. As-is situation. Plus, also a sort of prediction. What will happen if we do business as usual? So business as usual is every 20 year some kind of renovation to keep up to standards, stuff like that. So business as usual, the starting data. The second set of data is the context information, and context information helps us to deal with uncertainties of the future. It's explained by Han. Some parts of the future we cannot control, and even some parts we cannot even predict, like the energy prices or the interest rates in the future. But they are still very important. And when you calculate the return on investment for a PV panel, those 2 factors are determining whether it's a 6-year or a 12-year return on investment. And maybe with 6 years you will do it, with 12 years you might say, it's not good for me. But it's technically there's nothing different, but it's only those variables you cannot control. And the third part is the alternatives. What you can control, your choices. Do I put PV panels on the roof, or do I select a city heating connection? So these 3. So let's go a little bit deeper on the context information. Because predictions are very difficult, especially when it concerns the future. And Mark Twain once said that, and he's right, of course. So what we typically do is that we use what we call the scenario analysis approach. And people at Vito are elaborating that now as we speak, I don't know, but this task that is going on at this moment that just started a month ago. And the basic idea is that you define a context, so a possible future, and that you later check your alternatives, the choices you made, whether and then you check whether the alternative still performs good enough in this possible future. And typically, this is an example, so I don't know whether we'll use it, but typically you define 4 contexts. And it's a 2x2 matrix, so that's not too complex, but so you have 2 axes, one horizontal, one vertical, and this gives you 4 extreme contexts, 4 extreme possible futures. Now, in this example, which is a study 2011 about urbanization scenarios, so people thought about it a lot, and it probably makes sense, but we will investigate that. They identify 2 axes. So one is either it is a top-down approach, is the common approach in our cases, or it's a regional bottom-up approach. That's one of the axes, and the other one is vertically. It's sort of at the top of capitalistic, so economic values are most important, or the opposite, the ecological values are most important. So this will give you 4 scenarios, and so in a scenario study you make good stories for each of these scenarios, plausible stories. Maybe you're not in favor of the left top one, but it still might happen. And maybe you are in favor of the left one or the right at the bottom. You might be in favor of that, but you cannot control it. So each of these contexts contains the same set of variables, but they can have different values. Like the interest rate. So maybe the interest rate. No, I'm not an economist, but when you have economic values, the interest rate might be higher, and if it's ecologically values are important, the interest rate might be low. So that's what you define, and then the next step is what you do. You select, or you also define a sort of a reference context. So somewhere in the middle, what you think is most plausible. You don't know where it is, but you define it as a fifth context. So what you would typically do is you copy the four extreme contexts. It's the same as what we saw with the KPIs from the is it this screen? Yeah, from the public. So somebody has done that before, and you just copy the four extremes and scenarios, and you context. And you copy them to the right side of your screen, and there you change them. And so maybe your values are a little bit different, or you need some additional variables. And you do the same with the reference context. You define it with the same set of variables, and you set the values. The next thing you do is define your alternatives, and then check whether how these alternatives perform in the reference context. So we have the two alternatives, PV panels and district heating. You calculate the scores, then you select one, and then the next step is check the one alternative you selected, and check it in the four extreme. And then you can see how robust is my alternative in case there is a next crisis, or in case oil prices will rise into the sky. And so you can see how robust your solution is. So that's a way we propose to deal with the future, and we would also like to have your feedback. Whether you think this is necessary, this is helpful, or is it overdone? So we'd like to have your feedback on that. Oh, this was about data collection.
Yeah.
Anders,
let's continue then with the dashboard demo. As I told you, we already did analyzed our problem. We put an overview and we selected some KPI. And very important, we also connected modules to the KPI. So what I want to do now is that I want to go to the next part, is the collect data part. And here we have the context page, and it's currently empty because we didn't yet define this. So, but Bart told you everything about that. So I just click the next again, and I come to a very important page for this demonstration, and that is the two KPIs that we defined previously. Their individual settings for input. So what I would like to now click on one of these, the first KPI here, and what I will see now is actually the specification for input from the module. So you can see this page as a page from within the module, but it's shown in the dashboard. So that the module actually sends a specification for how this page will look. This means that the dashboard has a setup of controls that in the top here you can see that there is a number. So For this cycle analysis calculation, we will use 50 years. Okay, so that is what Erasmus just sent now to the dashboard. He wants this, and then we have started to make a list component here. So you could have a list of things that you could provide to the module. So maybe you could have a file that you export from some place and you upload it now through the dashboard, but it's going to be an input to the module. But right now I don't have a file to upload, but I can add posts now in this list manually. So that I will do, and I will click add. And what Rasmus also did, he said, I want a list, but I also want a list where every part in the list should have this definition. So this is a simple example of things that you could do. You could have texts, like for example, I take, say, building A here. I could have some like this drop-down boxes. That for this example, we will have building, and we will define their heating system. So individual gas boilers and annual heat energy use. This is a number here, kilowatt hour per year. I will save this to the list. I will, for the sake of this example, add some new buildings here with different settings. This, so we can take 3, each with different kind of heating system, like that. So there is a possibility, if you don't have any file to upload or something, you could almost define this by hand, manually. But ideally, you find this data somehow, or the module will find it somewhere else. You don't necessarily need to put it through the dashboard, but we have this flexibility, the option to actually define inputs in a quite sophisticated way through the dashboard. So a number and a list for the LCA module from Rasmus. I will accept this and go to the next KPI, which is the PV production. And René, he did define another kind of input. He said he wanted some geographical data. And in this case, I actually did a upload functionality for a file. So we will do that. Imagine in the same way here that you didn't have a data file. You couldn't export the data file from another system, database, or application. So you could actually draw buildings by hand on the map. It would be a little bit tedious, but there's a possibility, because sometimes you don't have all the data, or you need only simple data. It's a different case for every module. So the flexibility is a key point for us. But in this case, I have a file from René also that that shows the example of already having exported a file from a GIS system or something. So here we have the buildings of Rybrook, and in the same way that the list could define what everything in the list should look like, we could also define here what every building on the map should look like. So if I click a map, René has specified that this is the settings for the individual buildings. And again, this is also a simple example. Let's not focus on exactly what is done, but sure it's also interesting. But the thing is the flexibility to put in now individual data from every building here. In this case, it's already defined in the file that we uploaded. So really, we don't have to do anything else. And this is the optimal situation, really, that you already have a file that, or access to the data. You don't have to do too much work within the dashboard for the input. So I click, now I'm satisfied with the file I uploaded, and I click next KPI. Okay? So for now I can say that we have, for every KPI, for the module connected to the KPI, we have defined what the KPI or the module needed for input. So this is a work of the facilitator to provide this. And I will click next, and when I click next I will move to the ASIS tab of the venue. Okay. So now we're not on the collect data anymore, we're on the ASIS. And now comes the really interesting part, and Rasmus is sitting and waiting for a long time, and maybe, I hope he's still there. But actually what we will do now is that we will calculate these KPIs, which, if you remember the picture from Bart, means that from this dashboard, which is actually running now in my browser here locally, I will send to the server in Ireland a request for saving a request for a calculation. And then the server will send to the framework a request that every module that is called this and this will now start to calculate and use this and this data. So the technical setup here is quite complex. Ideally, Rasmus modules should start working when I click calculate all and send back me some output. So I press calculate all. And you can see something happening. Oh yeah, that went smooth. So Rasmus module here sent back a success signal, and also some value, an overall KPI value actually. And the same thing happened with René's PV module. It calculated successful, but what we want to do now is that we want to go to Rasmus to see what happened really behind the scenes. So, Rasmus.
All right, time to shine. So yesterday we had a lag ghost, so nothing worked when it really had to work. Now it did. So I don't know, how large part of the screen do you see here?
We see quite a lot of the screen, but a little part of your link-only window. So we see the console window we see quite much of. And now we don't see the link window anymore. So this is the module. It's very exciting, isn't it? It's like a black window with code in it. And the module could be anything. It could be a really nice graphical software where you could see things and manipulate things. It can also be like this. It's just a calculation kernel. But we will show you something more about this.
Okay, so you see now probably the whole this black window at least.
Yes.
Yeah.
And I'll just begin by showing you a little bit here what happens. So this is a little program I'm running that is the module, and that's communicating with the dashboard, or actually communicating with the IoT server. So the first thing that happens when you start the model is it connects to the server, and it's registering itself somehow and subscribing to the right communication channels and so on and so forth. So that's what's happening here in the beginning. And then a little bit later we get this request. It says get models. So that's it's sort of a conversation protocol between the dashboard and the modules. So the dashboard says to me get models, and that means I want to know what models are there. And my model then responds, well, here I am. Basically, here's my unique ID, here's my description of myself, what this model is. I'm saying I can deliver the following KPIs, the energy KPI and the greenhouse gas KPI, so on and so forth. And then you talked for a long while, and then eventually you did select model. And that's when you were in the KPI box, and you chose that I would use the renewal tool to calculate this energy KPI. And at that point, my module, can you see all this, the white marking here?
Yes.
Yes.
Yeah. So at that point, my module sends back a message specifying how the input for the module should look. So it says something like there's a time frame for the calculation. There's a label for that. Say something understandable for humans. it says something about a default value and the type of the data and so on and so forth. It also says that we're going to have a list of buildings with the following specifications, choose between individual gas boilers and district heating and whatnot. Yeah. And then I also actually see a select model, and this one I know was sent actually to Rainier's model, the PV model. So I didn't respond to that one. And then eventually came the start model request, which is when you actually want to do the calculation with all the data that you input. Yeah. And then I sent back that now I'm processing. So it's just a status update to say, yeah, I'm working on it to make the interface of your site more responsive. And then when the calculation was done, I sent back a message with all the KPI values and so on and so forth. So this is unintelligible, but the dashboard knows what to do with this data, and then you can present it in a nice way.
Yeah, we can look at that right now, how it looks in the dashboard.
Yeah.
Should we do something fun? Should we try to press calculate again and see if it's happening something at your place?
Yeah, let's
maybe.
Please let me first show the Excel file.
Oh yeah, of course, that's very important.
Now we see the module of Rasmus. So put it on the left upper corner on your screen. If you don't.
Yeah, I'll open it here.
Ah.
So actually, what's behind here is
You have to go more.
an LCA-based calculation model that some other people at SP developed. So I'm definitely no expert in this field, but I understand the basics. Okay, so it's a big Excel sheet with a lot of things in it, and all these green things here, all the green fields, is inputs that you can type into the LCA calculation, and then you get out results for what is the effect in terms of energy use and greenhouse gas emissions of retrofitting a building or renovating in some way. So this is a very big tool that can be used to calculate a lot of different things. And the use case we did here is that we are interested in a small portion of this. Maybe only what the energy or greenhouse gas emission effect is of changing the heating system in the building. So that's actually, you go down here and you find a drop-down list. Oops. Here, maybe you can see this.
So Rasmus, I got a request for a little speed up because there must be some time for discussion. So if you could focus on what goes in and out, then yeah.
So actually what Andreas did is he chose some heating system in the building. It goes in here. You see that this whole thing is in Swedish, but that doesn't matter because I created an English interface for it. And then at some point we go to another tab here, and these are the output values that would come out. And then actually when this module here runs, it goes into the Excel file, it changes some of the fields, and then gets out the result from this tab. Copies them out and sends them over the internet back. And that's what's being shown here.
So basically what he's doing, this is an existing Excel file, and what we showed is that you can, some of the input data, you have to prepare it, but some of the input you can ask from the dashboard user, and the other 200 fields you already have prepared, and then you can give some cells back as output after you have done the calculation. So that's what this example shows.
Exactly.
Yeah, and that's a nice thing because what it shows is Actually, programming this whole black window took me a few days, but making the actual connection to that Excel file took me about an hour when I knew what to get out. And there's a lot of things implemented in Excel around the world, so hopefully we can connect more of those quite easily now.
So, very good, thank you. So, since we need to have some more time for discussions, I could wrap up the demo now to just show a little bit more about your output and also the next output. Okay?
Yeah. Okay. Thank you, Rasmus.
Thank you, Rasmus. So,
cheers. Bye.
Bye-bye. So what he did is that he sent me one KPI value back that is here shown in the context of our excellent and bad, what we put in the configuration of the KPI. So between 0 and 1200 the mean value is like this, but also he sent individual values for all the buildings like this. So this value is just telling something about the overall, but if you want to see the individual buildings, we can show that as well. And now I want to go to Renier's output, because he has a little bit different output. He says also one mean value for his potential of PV module, and 0 was something bad, and 2000 was excellent, so we are in the middle here. Also he sent me an example of a list, but that is we already saw. So, but geographical outputs exist on the map. So he sent me back some geographical output. So if I click on the map, I can see that he did something with the shapes, the buildings that we sent as an input, and now we are showing the KPI values here on the map with a color range. So the green is a good value, and the red is a bad value. And
there's also yellow, and on this screen you can see the difference, but on the big screen here you cannot see the difference between green and yellow.
Green here, yellow here, and a little bit red here. Yeah. So this is probably this building has some higher, some lower potential then. Okay. But I won't go into detail now. This is some kind of outputs that you have seen. We will have more kind of outputs. So we will continuously try to make the modules send us different things to show in the dashboard. So it's up to the modules really. The dashboard will be very flexible showing stuff. So with that, I would like to thank you, and this is a dashboard demo. It was a proof of concept for a technical part of the dashboard, so I hope that with a few screens you could feel the sense of what's happening behind the scene.
Okay. So thank you, Andreas. So now we go to the easy part, the PowerPoint, because Andreas showed the first 3 steps, and I will give you a little impression about the next 4 steps, how this will look like. So, first of all, you have to know that we don't look only at those 2 energy-related KPIs. So we want to have the whole circle with environment stuff, the people stuff, society, do I feel safe, do I feel comfortable in this area. Economic part, return on investment for housing cooperation, but also cost of living for the inhabitants. And the process part, did I involve all the stakeholders correctly and in time. So we are, in the end we want to support all KPIs, but of course in each case you will select the number you think are important for your decision. And this is the way we want to present it, with colors and also with size, which represents the importance. So, what we have seen, the left side, the as-is situation, so the energy consumption is not too good and the PV potential is not used at all, or there are a few PV panels there, but not by far not enough. So what we want, and you can imagine that you can set the ambition level on the scales you defined before. So we want from orange and red, we want light green and dark green. That's but what we when we visualize our ambition. And of course you will do that for the whole circle in the end. So the next thing you do is step number 5, develop alternatives. You will develop some, or you make some choices, or prepare some choices. Now in this case, one would be to use PV panels, another one would be to use PV panels, but also to do something about the height of the buildings, and so demolish some of the low quality high buildings and replace it by row houses to get different people, to more a mixture, diversity in the area, or district heating. And so you do that in a separate module, but so the administration of those alternatives you do here in the dashboard. This is an example of the second alternative, PV with lower buildings. So you introduce row houses in the area. You stimulate PV for private owners, because that's half of the houses is privately owned. So you have to do a kind of program to stimulate them. And for the other half, the housing corporation will say, I want to invest, or you invest it together with the energy company. And like Paul, he's thinking about sort of renting the roofs of his complexes to the energy company, and then the energy company can produce energy, and maybe they are from then on responsible for maintenance of the roofs or the whole building, whatever. So some kind of trade-off Paul wants to make. You define your alternative. Maybe it's also like in a data file with all the necessary data. Then you start calculating, and what you do, you select an alternative with a context, a possible future. Now in this case, the PV panel option, lower buildings, and the reference context. So that's the first one I want to calculate, I want to assess. And then you get potentially a screen like this. And on the left side, the as is situation. In the middle, your ambition. And on the right side, you have the scores of this alternative. So from red, orange, you want it green, and this option is orange, greenish. So, is it enough? Nah, maybe you improve this alternative, or you try another alternative. You can play, you can go back and forth in the steps, and then even in the end you get your ideal solution. And of course, because you look at all the aspects, all the KPIs, it's not only relevant for the housing company or optimal for the housing company, but also for the inhabitants, the energy company, the water board, the city, everybody. And of course you can imagine that you have different views here, comparing 3 alternatives or 1 alternative in 3 contexts. But that, and we think this will be sort of the final step. So there is a 7th step. Select the best alternative, but maybe we don't even support that with a computer program, because we say this is what you have. You can have a lot of views and look at it from this side and that side, and then in the stakeholder group you make your own decision. Nothing. Maybe it's not even computer supported anymore. But this, I think, this is the final, most important step that hopefully will start discussion. And then you can go back and forth, but this will start discussion and also gives confidence to to stakeholders that they are not alone in this, and that they have a very good, that they have a good solution which is also acceptable for them and for others.